So the turning effect of the force, when we apply the force on the object and the object rotate, we call that as a moment or turning effect of force. And it can be a moment can be clockwise or it can be anti-clockwise. So when we apply the force on the object about a pivot, the object will rotate and we simply call that as moment. Example of moment like opening a door, that is one example, or loosening or tightening the nut using a spanner or the wrench, or lifting a load with a wheelbarrow, that is also example of turning effect or moment. So when we apply force and the object rotate, we simply call that as the moment. If we want to calculate a moment, the formula which we use to calculate the moment is equals to force multiplied by perpendicular distance from the pivot. Pivot means the point where the object is fixed. So region or the point where the object is fixed, we call that region as a pivot. So when we apply force on the object, the perpendicular distance from point of action of the force to the pivot, that is known as the moment arm. The perpendicular distance from where we apply force to the pivot, that's called moment arm. So moment is a product of force multiplied by moment arm. The unit of the force is Newton and SI unit of length or distance is meter. So Newton meter is there, but other unit acceptable Newton centimeter or Newton millimeter. It is a vector quantity. When it's a vector quantity means it is having a direction. So what are the directions for the moment or turning effect? Either it will be anti-clockwise or it will be a clockwise. So it depends on the direction in which we apply the force as well as the distance as well as the position of the pivot. So both factors decide whether a moment or turning effect will be more clockwise or anti-clockwise. If we want a resultant moment, if you want to calculate the resultant moment, so if the moments are acting in the same direction, to get the resultant we will add them. But if you want to find the resultant moment and they are acting in opposite direction, to get the resultant we will subtract them. So if I say an object is there which is pivoted at the center, so this is a pivot, we are applying the forces. So one is trying to cause a clockwise moment, another one is trying to cause an anti-clockwise. Here's a pivot. So in this case, because the two moments are in opposite direction, to get the resultant we will subtract. And opposite will happen if we apply the forces. Forces can be in different directions, but the moment we have to check, the force F1 is also causing a clockwise moment, force F2 is also causing a clockwise. So if you want to calculate a resultant moment due to two forces, in that case, we will add to get the resultant moment as the two moments are in same direction. So it depends on the question. If they're in the same direction, we will add. If they're in opposite direction, we will subtract. Is it clear? The introduction of the moment definition as well as the formula to calculate the moment. Any doubt till this point? The moment of a force can be increased. If we want to increase the moment or turning effect, we can apply a higher force rate or we can increase the distance from the pivot. If we apply a higher force, in that case, the turning effect will increase, the moment will increase, or we increase the distance between the force and the pivot, the turning effect will also increase. A word example, a boy loosened the nut using a spanner. As you can see, that is 0.5 meter long. So we have the distance that is 0.25 meter long, and he's applying a force of 50 Newton. So to calculate a moment, that is the force multiplied by perpendicular distance. In that case, it will be 12.5 Newton meter. What is the principle of the moment? It states that if the total clockwise and anti-clockwise moment are balanced or equal, the object will be in equilibrium or object will be balanced. So if an object is in equilibrium or object is balanced, in that case, the sum of clockwise moment, the total clockwise moment will be equal to total anti-clockwise moment. Like if one side is causing a clockwise moment, the other is causing an anti-clockwise. So if it is in equilibrium or it is balanced, then the both moments will be same. What are the conditions for object to be in equilibrium? The two conditions are there. When object is in equilibrium or balance, number one, there should be no resultant force. And number two, there should be no resultant moment, or we can also say the clockwise moment must be equal to the anti-clockwise moment. Example, the diagram shows a uniform. When they use the term uniform, it means the weight is acting at the center. So uniform half meter rule is there or scale, which is balanced at the midpoint. So when they say it is balanced, whenever object is balanced or equilibrium, so what we say the clockwise moment or we can say the anti-clockwise moment is equals to the clockwise moment. This is possible when the object is balanced or equilibrium. So as you can see, 100 Newton weight is causing an anti-clockwise. A metal block is causing a clockwise moment, and moment is force multiplied by distance. So this is a force which is 100 multiplied by distance from the pivot. It is 15, and the force which we don't know for this weight of the object, say W, and the distance from the pivot is 20. So if we need W, that is equals to 100 multiplied by 15 divided by 20. So when we solve, it will be 5 multiplied by 15, which is equals to 75 Newton. And it is obvious when we want to balance the two objects, the heavy objects are always placed closer to the pivot and the lighter objects are placed away from the pivot so that they can balance with each other. If they were having the same distance, if two objects have a different weight and we place them at the same distance from the pivot, the beam can never be balanced. Why we did not include the weight of the beam? Because as they mentioned that it is balanced at the midpoint, so it means the weight of the beam, weight of this plank or a ruler is acting at the center, so it is acting on the pivot. It does not contribute to either clockwise or an anti-clockwise moment. Is it clear, this question, how we work out the weight of a metal block using the condition of equilibrium in which it states that the beam is balanced? Any doubt till this point? Now we'll do some questions related to the moment topic. So this is AS level assignment related to topic moment or turning effect. You don't find many questions in the past paper because this topic is included last year, so you don't find too many questions related to turning effect. So for practice, you can use IGCSE questions. Now, as you can see, there's a uniform plank which is having a length of 5 meter. So when they mention a term uniform, what is the meaning of this term uniform? It means the weight is acting at the center. That's why we call that as uniform. So it's having a length of 5 meters. So total length is 5. So where the weight will act at the center. So it will act at the center, which is 2.5. And a ray of 200 Newton is placed across a stream as shown in the figure. So what we do, a uniform plank is there of plank AB of length 5 meter and weight 200 Newton is placed across a stream as shown in the figure. So the supports are there, the normal contact force that is acting upward. So this is a normal contact force from the ground that we call that as FB, and this one we call that as FA. Both are acting upward. Weight of the plank is acting downward. Weight of the person is also acting downward, and person is at a distance of x from the pivot. But whenever, as you can see in this question, there are two supports. So when two supports are there, it's up to you. Any one of the support you can take as a pivot. Because if I take a support A as a pivot, so there will be no moment by FA. All the moment will be caused by FB, weight of the plank and weight of the person. If I take B as a pivot, then FB does not contribute to moment. Only FA will contribute, the weight of a person and weight of the plank will contribute to a turning effect. So whenever two supports are there, always remember it's up to you. Any one of them you can take as a pivot. So what they mention here, a man of weight 880 Newton stand at a distance x from A and A. The ground exert a vertical force Fa on the plank at end A and Fb on the plank at B. As the man moves along the plank is always in equilibrium. So it means it is always balanced. Explain why the sum of the forces Fa and Fb is constant no matter where the man stands. So what is the reason? Even a man is at this position. If a man moves to a new position, but the sum of Fa and Fb won't change. So first thing, whenever we write the answer, because as I mentioned, it is in equilibrium. So for object to be in equilibrium, there will be no resultant. So there will be no resultant force on the plank. If there is no resultant force, or we can also say the upward force is equals to the downward force. So upward force is equals to the downward force. What is the upward force? Fa is acting upward, Fb is acting upward, and what about the downward force? The downward force is the weight of the plank, which is 200, and weight of the man, that is 880. So the total sum will be 1080 Newton. And as you can see, it does not depend on where the person is standing, because there is no distance involved here. So first thing, you will mention that there should be no resultant force as the plank is in equilibrium, or we can say upward force equal to downward force. So Fa plus Fb should be equal to 1080, which is independent of the position where the man is standing. Is it clear, the first part? Then for the second part, they're asking a man stand at a distance x, which is 0.5 meter. Use the principle of moment. Calculate the magnitude of Fb. So how we can calculate? The x is given how much? 0.5. So it's up to you. Any one of them you can consider as moment, but we need Fb. You can consider as a pivot. So we need FB, so we'll consider A as a pivot. So if A is a pivot, 880 will cause clockwise moment, weight of the plank will cause a clockwise moment, and the vertical upward force from the ground will try to cause an anti-clockwise moment. But because it is balance or equilibrium, so we can say the clockwise moment is equals to the anti-clockwise moment. So the clockwise moment, the weight of the man, which is 880, multiplied by distance from the pivot, that's 0.5 given in the question. 200 is also causing a same direction moment, so 200 multiplied by distance from the pivot because it is acting at the center. So if the total plank length is 5 meters, so this distance will be 2.5. Equal to anti-clockwise moment, so it will be FB multiplied by distance from the pivot. So what is the distance from the pivot? Because the total length of the plank is 5 meters, so this will be 5. So it will be multiplied by 5. Now we solve 880 times 0.5, that is 440, plus 200 multiplied 2.5, that's 550, sorry 500, and 5 is multiplied, other side it will be divided, so this will be divided by 5. So the resultant force that we will get as 188 newtons. Is it clear, this part, how we work out the vertical FP by using the principle of the moment? Then as how to know FA, so how to find FA? We know the FA plus FB is equals to 1080. So we know FB, so FA is equals, FA plus this 188 is equals to 1080. So FA is equals to 1080 minus 188. So 1080 minus 188, that is equals to 892 newtons. That will be FA. But why we did not include in the moment? Because it was acting on the pivot, so its force is there, but it does not contribute to a turning effect. They mention the variation with distance x of a force as shown in the figure. So F is varying with the distance. As you can see, the x is basically the distance of the man from the end A. On the axis, sketch a graph to show variation of FB. Because we know that total upward force equal to total downward force. So it means the sum of FA plus FB should be equal to 1080 Newton. So we have to complete this graph. So what it appear? It is, if FA is like each box is representing 50, so it appear 950. So if FA is 950, what should be FB? Because the total sum is 1080 as 880 and 200, so 1080 is there. If out of 1080, if 950 is FA, so 1080 minus 950, so it will be about 130. So what will be the value for FB? It will be about 130, like you can start mark somewhat here. Then you can take different values. Like example, if FA, the values which are easy to understand. Like example, if this point for FA, so this is 500, 600, and 700. So if FA is 700, then FB will be how much? Because FB is 1080 minus 700. So 1080 minus 700, that's 380. So FB will be 380 at this point. So this is 100, 200, 300, 350. This is 400. So it will be about 380, somewhat here. And what about the last value? If FA is 100, if FA is 100, what about FB? The FB will be about 1000, because 100, 1080 minus 100, that will be 980, somewhat here. So when we join the points for FB, it will be like this. Is it clear how we complete the graph for showing the variation of FB? Because the sum of FA and FB should be 1080, so all the points, the sum should be 180, 1080. Any doubt in this part? Then another question, how we define a torque of a couple. What is the meaning of torque of a couple? So when we simply apply a force, like example, so what is the meaning of a torque of a couple? We have an object which is pivoted at any point. For example, this is a point of rotation or a pivot. So when two forces causing a same direction of moment or turning effect in the same direction, we call that as torque of a couple. So if I say this is force F and the distance from the pivot, say R1, and this is also force F, same force F is there, and the distance is R2. This is causing an anti-clockwise moment. This is also causing an anti-clockwise moment. The distance R1 and R2, the total length of the object or the distance between the forces, example, that is D. So D is actually a sum of R1 and R2. So when we calculate the resultant moment, in this case, because the two moments are in the same direction, so we will add, so force multiplied by distance R1 plus the force multiplied by distance R2. If I take F common from here, so if F is common, it will be R1 plus R2. And R1 plus R2, what is R1 plus R2? R1 plus R2 is equals to D. So the resultant moment when two forces, identical forces, are causing a same moment, a moment in the same direction, what we call that? We call that torque as of a couple. So when two forces, identical forces, produce moment in the same direction, it is known as the torque or the turning effect or the moment due to the couple. And how we can calculate the torque due to couple? So it is basically the force multiplied by distance between the forces. So if you multiply force with the distance between the forces, if the two forces are causing a same direction moment, we simply call that as torque due to a couple. Is it clear? So the concept of the torque due to a couple. So basically, identical forces causing a moment in the same direction is refers to a torque due to a couple or moment due to a couple. So in the first question they asked define torque of a couple and it's of 2 marks. So how you explain torque of a couple? So torque of a couple is the force multiplied by distance between the or perpendicular distance between the two forces. Or the first explain or you can also write, this is basically explaining the idea, the formula. You can also write the torque due to a couple, or you can also explain torque due to a couple, that when identical forces produce a moment in same direction, it is known as torque due to a couple, which can be calculated by using a formula force multiplied by perpendicular distance between the two forces. Torque and moment is the same thing. There is no difference between them. Okay. In this question, a wheel is supported by a pin P at its center of the gravity as shown in the figure. So what they mention, the plane of the wheel is vertical, like it's on the vertical plane, and the wheel has a radius of 25 centimeter. Two parallel forces are there, each of 35 Newton, act on the edge of the wheel, which are vertical directions as shown in the figure. The friction between the pin and the wheel is negligible. List two other forces that act on the wheel and state the direction. So what will be the two forces that will act on this wheel? Number one, there will be a weight of the wheel which will act downward. So weight of an object, weight of the wheel, that will act downward. And there will be a normal, because it's in contact with the pin, so there will be a weight of the wheel that is acting downward, and the normal contact force from the, there will be a force from the pin on the wheel that is acting upward. So there will be the normal contact force from the pin onto the wheel, which is vertically acting upwards. The next part, calculate the torque of a couple. So how we calculate a torque of a couple? The torque of a couple, basically, it's a direct formula. Resultant moment when two torques are in the same direction by the identical forces, that is known as the torque of the couple. And how we calculate this? We calculate by using a force multiplied by distance between the perpendicular distance between the forces. So force multiplied by perpendicular distance between the forces, that will give us torque due to the torque of a couple. So the force, that is 35 multiplied by perpendicular distance, because the radius is 25, so this will be 25, and this is also 25, so 25 plus 25, this will be 50 centimeter or 0.5 meter. So when we multiply 35, and so it will be 17.5 Newton meter, and the direction, that will be anti-clockwise. Is it clear? The moment of the couple. The next part, the resultant force on the wheel is zero. Explain by reference of the four forces how it is possible that the resultant force is zero. So with reference, why the resultant force is zero? Because basically 35 Newton is down and 35 Newton is up. That is zero. And the weight which is acting down balances with the normal contact force which is upward. That's why if this was example of 5 Newton, this is also a 5 Newton, so that's why they will cancel out and the resultant will be 0. So the question is, resultant force on the wheel is 0. Explain why. So the two 35 Newton forces are equal in magnitude, opposite in direction, and weight and up, which is downward, balances with a normal contact force. So 35 Newton forces are in opposite direction, and the weight balance with the normal contact. So there is no resultant force. State and explain whether the wheel is in equilibrium. So for object to be in equilibrium, what are the conditions for object to be in equilibrium? So there should be no resultant force, and there should be no resultant moment or turning effect. So when you see about the resultant force, you can clearly see there is no resultant force. Upward forces balances with the downward force. So first statement is true. But what about the resultant moment? That is not true. Why? Because this is rotating anti-clockwise. So resultant moment is not zero. Resultant force is zero. So state and explain whether the wheel is in equilibrium. You will say no. And the reason is because there is a resultant moment acting on the wheel. Is it clear, this last part related to the moment?